This conference will now be recorded.
Okay, I think everybody have the softwares folder. Okay, and from the softwares link, I need all of you to download and install only the livewire PCB wizard file. Okay, if you open the drive link of softwares, you will find 3 or 4 different softwares like Eagle, EasyEDA and livewire PCB wizard. Okay, only download and install the livewire PCB wizard file. Okay, it is enough. Okay, it is a combination of 2 softwares. If you downloaded the single file, it will give you 2 softwares. Okay, did everyone downloaded the software from the drive link that you have? Please respond quickly. Okay, if you install the livewire and PCB wizard file, you will get 2 different tools in your
Is it available in
desktop.
Play Store, sir?
Okay, that is not available in Play Store. There is a drive link provided for you in the mail itself. Livewire and PCB wizard. Okay, I think everybody have the
I
drive link.
didn't receive any mail from you, sir.
Okay, or else just give. Okay, in the course content PDF file, you will find the drive link also. Just go through it once, or just give us a minute. We will share the link in WhatsApp group. Okay guys, check your WhatsApp. I have shared the drive link. Okay, from the drive link, download only the livewire and PCB wizard file. Okay, no need to download the remaining two folders. Just download the PCB wizard and livewire. Okay, this folder, only that software is enough. Okay, if you downloaded it, it will be look like this, and if you double click on it, it will ask you to install it and give necessary permissions for the application. So after completion of installation, you will get two softwares like this. If you observe the screen on the left side, you will have we have two softwares, right? Livewire and PCB wizard. Okay, like that, two different softwares will be installed in your PC if you downloaded and install the livewire PCB wizard file. Okay, please complete it quickly. Today we are late for the class.
So, so can you please repeat once?
Okay, Mister, I did not get you. Come again.
Can you please repeat once, sir? Once, can you please repeat?
Okay, I haven't told you anything. Just download the software from the link that I have shared in WhatsApp. After downloading, you will get okay. After downloading, you will get a file like this, livewire PCB wizard. Okay, just install it. After installing that software, you will have two different tools on your desktop. Okay, after installing, if you observe my screen, here we have two different softwares, right? Livewire and PCB wizard. Those two files will be installed in your system. Okay, just make it fast. I will give you 5 minutes. Okay, that is a small file. It will be done in few minutes. If the installation is completed, let me know in the chat box. Then we can continue with the class. Okay, it is completed for one. Just make it fast. Now it's 4:20. I will begin the class in 4:25. Okay. Okay, just make it fast. You have 2 minutes. Okay guys, after installing, you will have 2 different folders on your desktop. Okay, these are the 2 files. I need all of you to okay, just open the liveware. Okay, sorry for the disturbance. Okay, I need all of you to open the liveware software, okay, which is an interlink tool for PCB wizard and it has nothing to do with PCB designing. Okay, after opening the software, just you will get a getting started liveware window. Just close. Okay, this is a software which is used for designing circuits. Okay, I think the electronic students are familiar with MATLAB like that, no? Okay, in MATLAB or multisim, we will design some circuit and we can observe the output of those circuits, right? Similarly, this livewire tool also is used for designing some electronic circuits only. Okay, it is not used for designing any PCBs, just it is used for designing some circuits. Okay, before designing the PCB layouts, we Okay, is it audible now? Guys, is it audible now or still it's breaking?
Yes, sir. Audible.
Okay, thank you. Okay, guys, after opening the software, okay, just let me know if it is completed for everyone or not. Respond in the chat box. Okay, thank you. Okay, now all of you open the Liveware software. Okay, it is a dummy tool which is used for designing some electronic circuits. Okay, coming to the introduction of the tool, there is nothing, just we will have some tools, that's it. Okay, just from the file edit view, these are common options which will be available in each and every window that we are familiar with. Okay, in file we will have new file, open, close, save as. All these are common for each and every window. And in edit also we know all the details like cut, copy, paste, delete, etc. And in view also these are similar functions which are available in regular Windows, right? And coming to the shortcuts, okay, this is a shortcut for open, and next save, print, cut, copy, paste, next undo, redo. Now after designing any of the circuits in Liveware, we can check the output of that circuit by running the circuit. Okay, if you click on the run or if you click on F9 directly, your circuit will be in simulation. Okay, next, and if you want to pause the simulation, you will click on pause button, and if you want to stop the simulation, you can click on stop button. Okay, once your circuit is completed, after running your circuit, if you want to make some modifications to your circuit, then you need to stop the simulation. Then only we will be able to make changes in our circuit. Okay, next, coming to the select tool. Whenever we are dealing with the components or component footprints or symbols, sometimes we need to drag the circuit and sometimes we need to zoom in and zoom out. Okay, when we use these tools, if we want to get back to the normal, then we need to click on select tool. Okay, then only you will be having normal functions. Okay, otherwise if you select the zoom tool or delete tool, it will be in that mode only. Okay, if you want to change it to normal position, you need to click on select tool. Okay, after that you will have graph. Okay, for some circuits we can add the graph and check the graph in output also. And in the last, if you observe it, it is gallery, right? If you place the cursor on it, it is showing that it is gallery. Okay, gallery is nothing but the entire electronic component symbols. Okay, now if you sometimes your gallery gets closed, then you need to click on the gallery icon which is present at the top side, then your gallery will be appeared. Okay, now coming to the left side options which are available. After completion of your circuit, you can check the, okay, first of all it will stay in normal mode, then you can check the voltage levels of your circuit when it is in simulation, and current levels also. Okay, current flow through the circuit. Okay, if you change it to the voltage levels and current flow, you can observe the current flow also after simulating your circuit. Okay, now come to the gallery. The first folder is power supplies. Okay, gallery is nothing but we will find some of the basic electronic components which are used for designing electronic circuits. Okay, we will find maximum number of components. Okay, as it is a basic tool and This livewire is a dummy tool which is interlinked with PCB wizard. Okay, actually the PCB layout designing software is PCB wizard, but they interlinked livewire to it so that the beginners will be easily designing the circuits and they can design the PCBs for the circuits very easily. Okay, for the advanced softwares there will not be any simulation like this. Directly you need to design the circuit. After that you need to design the PCB layout for that circuit. Okay, is it clear till now for everyone? Please respond in the chat box. Okay, thank you guys. Now coming to the gallery, the first folder is power supplies. Okay, in power supplies you will have batteries, cells, ground, voltage rails. Okay, and some sources like AC voltage source, DC voltage source, and current source, fuses, and voltage regulators. Okay, all these are all circuit symbols of electronic components. Okay, make sure that these are all the circuit symbols. Okay, when going to the PCB designing, we will not be using any circuit symbols. Directly we will be using the footprints of components. Okay, you will get the difference when you go to the PCB designing. Footprints are different from circuit symbols. Okay, you will get the difference. Don't worry about it. Okay, in power supplies you will have all these circuit symbols. Okay, now click on the down arrow. The second one is connectors, single inline, dual inline, terminal blocks. Okay, you will know what is a connector is while designing the circuits. Okay, there is no need to explain about them now. After connectors you will have input components. Okay, if you open the input components folder, you will have buttons like push push button, SPST, DPST, okay, DPDT. All these are switches. Okay, switches comes under input components. Next, sensors like variable resistors, potentiometers, LDR, thermistor, okay, photoresistor, phototransistor. Okay, all these comes under sensors. Okay, can anyone define why the sensors are in input components? Why the sensors are in input components? Can anyone explain what is the reason behind it? Please respond quickly. What is the reason for placing the input components in, sorry, sensors in input components? They are bidirectional devices. Okay, that is not the correct answer. It senses the changes and then responds to it accordingly, so they can be input devices. Okay, you are almost there, Ms. Susmita, but that is not the exact answer, because the sensors collect information from outside, gives information to internal circuit. Okay, you're also there. Okay, I will explain the reason. Okay guys, remember, whenever you talk about sensors, okay, all the sensors comes under input components only. Why? Because they take some information from the environment or its surroundings and it gives the signals to our microcontroller or microprocessor. Okay, the sensor data is given as input to our microcontroller or microprocessor. Okay, then the data is processed according to the requirement. Okay, all the sensors collect information. It's collect some, okay, guys, is it audible now?
Yes, sir.
Yes,
Okay,
sir.
sorry for the inconvenience. I just have some signal problems. Okay, thank you guys. Thank you for your patience. Okay, where did my voice went off? Can anyone tell me?
After the explanation, sir.
Sensors are input.
Okay, when someone asks you about sensors, whether they are input components or output components, okay, blindly you can say that each and every sensor is an input component. Okay, they collect the data from the environment or its surroundings, then that collected information is transferred to our microcontroller or microprocessor as input. Okay, that is the reason sensors are in input components. Okay, and in input components we have signal generator and voltage generator. Coming to the next folder, passive components. Okay, I think everyone are familiar with the passive components like resistors, okay, capacitors, inductors, transformer, etc. Okay, all these comes under passive components. Okay, suppose whenever your circuit is required any of these components, you can open these folders and design the circuit. Okay, next discrete semiconductors. Okay, you will have diodes, Zener diodes, bridge rectifier, okay, transistors. All these comes under discrete semiconductors. The next folder is logic gates. Okay, suppose if your circuit consists any one of the logic gates, you can use the logic gates also, but we will not use any logic gates in our circuits for now. Okay, next coming to the integrated circuits. Okay, you will have some of the ICs like 555 timer IC, 556 dual timer, okay, and some operational amplifiers and some other ICs. Okay, and in 7400 series and 4000B series, you will have several other ICs also. Okay, like operational amplifiers and some other multifunctional ICs. Okay, if your circuit requires any one of these ICs, you can use them. Okay, next coming to the output components. After ICs, the folder is output components. In output components, we will have lamps, okay, buzzers, loudspeakers, okay, LEDs, motors, relays. All these comes under output components. Okay, if your circuit requires any LEDs or okay any segment displays or something like this, you need to click the output components. Okay, and the last folder is measuring. In measuring, you will have emitters, voltmeters, test points, okay, analog and digital multimeters, okay, oscilloscope, nothing but CRO, and logic analyzer. All these comes under measuring instruments. Okay, these are the circuit symbols which are available in gallery. Okay, now I just want to connect a simple circuit. Okay, we will try designing a basic example circuit. Okay, just I want to turn on an LED by connecting a battery to it. Okay, for selecting the components, you need to click on the component and just give a left click on the workspace. Okay, then your component will be placed. Okay, I have took a battery. Now I will just connect an LED to the battery. Okay. Okay, just for your understanding, I am designing the basic circuit. After taking a battery from the output components, I am taking an LED. Okay, now I am closing the gallery. Okay, I will just zoom in. Suppose if I use the zoom tool and now I want to come to normal position of the cursor, you need to click on the select tool. Okay, otherwise it will not change. It will stay in zoom option only. Okay, you need to click on select tool. Okay, now the components are taken. These are just two circuit symbols of battery and LED, right? Okay. Now, can anyone tell me what is the operating voltage of an LED? Please respond quickly.
3.3.
Mr. Tarun, can you come again? I did not get.
3.3 volt.
Okay, very good. Thank you for responding.
1.8 to 3.3 volts.
Okay, thank you. That is also correct answer. Basically, the operating voltage of an LED is 3.3 volts. Okay, but what is the voltage of my battery here? 9 volts, right? Okay, as I have already told you, the LiveWire is a dummy software. If you connect the battery terminals to the LED, it will turn on. Okay, but if you do it practically, the LED will blow off, okay, within few seconds. Okay, if you connect a 9 volts battery to a 3.3 volt LED, the LED will damage immediately. Okay, now if you want to rotate or drag your components, sorry, for rotating, select the component and you need to click on Ctrl plus R. Okay, for rotating the components, the instruction is Ctrl plus R. Okay, select the component which you want to rotate, then you need to click on Ctrl plus R. Okay, now I will connect the circuit. Okay, for connecting, place the cursor at the terminal of your component. Then you can observe 4 arrows, okay, indicating the point of the terminal. Then you need to give a left click and drag it for making the connection. Okay, after giving a left click and dragging, you will get the wire. Okay, then you can go to the other terminal where you want to connect the wire. Okay, and when you observe the 4 arrows, that means that indicates the terminal endpoint. Okay, then again if you give the left click, the connection will be established. Okay, again I will connect the circuit. For giving the electrical connection, go to the terminals of your component. Then you need to drag by clicking the left side of your mouse. Okay, and if you want to change the direction of the wire, okay, after dragging, you can leave the left side cursor. Okay, nothing but if you leave the left side mouse also, the wire will not disappear. And if you want to change the direction of the wire, just you can give left click so that your direction can be changed. Okay, you can change the direction of the wire by giving the left click on your mouse. Okay, like this you can change the direction also. Okay, I will just connect the battery to the LED. Okay, now if you observe, as I have already told you, this is a dummy tool, right? Now if you click on the run symbol, or if you directly click on F9, the LED will start glowing. Okay, but if you do it practically, the LED will get damaged immediately. Okay, now can anyone give me an idea how to protect the LED without burning, okay, or getting damaged? What is
By
the
adding
remedy that
resistors.
we have?
Using resistor.
By
Okay,
adding resistors, we can.
Using resistor.
okay, thank you for responding. Yes, by adding a resistor across the input voltage of the LED, we can protect it from damaging. Okay, for that, open the gallery, go to passive components, take the resistor, and if you want to rotate the resistor, select the resistor and click on Ctrl plus R. Okay, now give the connections. Okay, in practical way, if you do like this, the LED will not get damaged. Okay, now I want to check the voltage at the input as well as the output. Okay, because I have connected a 1 kilo ohm resistor here and I have used a 9 volts battery, right? Now I want to check the voltage because the LED will work at 3.3 volts, right? But I don't know how many volts is present at the LED anode terminal, right? For that, click on gallery, go to measuring, okay, which is the last folder. Okay, I am taking an voltmeter. Okay, I will take 2 voltmeters because I will check the input as well as output also. Just connect 2 voltmeters, one across the battery and other one across the resistor output. Okay, now if I run the circuit, okay, just wait a minute. Okay, I have connected 2 voltmeters, one across the input voltage and another one across the resistor output, right? Okay, now you can observe that the input voltage is 9 volts, and after using a 1 kilo ohm resistor, what is the voltage? Only 1.58 volts. Okay, that means I can reduce the resistor value to somewhat level. Okay, I can decrease the value of resistor. Okay, there is no need of 1 kilo ohm resistor here for protecting the LED. Okay, now if you want to change the values of any component, just double click on the component, then a window will be appeared with the properties of that component. Okay, if you double click on any component, it will open the properties of that component. Now check the value here. It is 1 kilo ohm, right? It is in kilo ohm, and here you can observe downward and upward arrows, right? If you change it to mega ohms, and if you down click on it, you can get micro and nano ohms also. Okay, and if there is no alphabet here, that means it is in ohms. Okay, only it will consider ohms. And if you click on the upside arrow, it will take you to kilo ohms and mega ohms. Okay, now I am changing it into 240 volt. Sorry, I am giving a 240 ohm resistor. I am clicking on OK. Okay, now I have connected a 240 ohm resistor. Now I am running the circuit. Now observe the output voltage. What is the voltage that is present at the anode terminal? 3.28. Okay, that is enough. We can use a 240 ohm resistor across a 9 volts battery. Okay, is it clear for everyone? Guys, please respond quickly. Okay, thank you. Now we will design another circuit. Okay, first of all, I forgot to tell you, just create a folder on your desktop and save all the circuits that you are designing, because you need all these circuits for designing the PCB layouts for these circuits. Okay, I will not give you the circuits again. You need to open your circuits that you have designed. Okay, save all the circuits on your desktop, and after saving your circuits, if you directly go to the folder and click on open the folders, sorry, if you try to open the files, they will not get open. Okay, they will give you some error. Okay, for opening any one of the saved files, you need to open the software first, then you need to click on open from the software. Okay, that means you need to click on file, then you need to click on open. From here you need to open the saved files. Okay, otherwise you will not be able to open the saved files. Okay, this is a basic circuit, right? for turning on the LED. Okay, just we connected a 9 volts battery and a 240 ohm resistor along with an LED. Okay, for checking the voltage across the input and output, we just use 2 voltmeters. Okay, I will give you the next circuit. If you saved this circuit, can I move to the next one? Okay, thank you guys. Okay, save the circuits. Don't forget to save. Okay, I am deleting the circuit. For making any changes to your circuit, you need to first stop the simulation. Okay, without stopping the simulation, you will not be able to make any corrections in your circuit. Okay. Okay, next we will design. I think everybody know the mobile charger circuit, right? Okay, I think everyone are familiar with mobile charger circuit, mobile chargers. Okay, that is nothing but a 5 volts DC charger. Okay, can anyone tell me the components present inside the AC charger? What will be the components present inside of our 5 volts charger?
Step down transformer.
Okay, step down transformer, very good. Any more answers? Any more answers? Step down transformer, bridge rectifier, filters. Okay, very good, Mr. Sonad. Okay, any more answers? Voltage regulator. Okay, Mr. Devakar, very good. Okay, those are all the components which will be available in our charger circuit, right? Okay, we will just design that circuit, a basic model of our 5 volts charger. Okay, nowadays we will have so many advanced chargers like super fast chargers and so on. Okay, the circuit that we are going to design is the basic version or basic model of a charger circuit. Okay, just open the gallery, and from the gallery, from power supplies, you need to take a AC voltage source because the input to our 5 volts charger is AC 230 or 110 volts, whatever it may be. Okay, just take an AC voltage source from the power supplies. Okay, after that, okay, after giving the AC voltage, what is the next step? First of all, we will be having a step down transformer. Okay, from the passive components, if you drag it to the bottom, you will have the transformer circuit symbol. Just take it. Okay, after taking the step down transformer symbol, what is the next step after stepping down the AC voltage? What is the next step? We need to convert the AC voltage to DC voltage. Okay, what is the component that is used for converting the voltage? Guys, can anyone tell me what is the component that is used for converting the voltage? Okay, very good, Mr. Lakshmi Narayana. rectifiers, right? Rectifiers are used for converting the AC to DC. Okay, can anyone tell me what will be the output of rectifier? What is the out? Okay, very good, Mr. Devakar. Pulsating DC is the correct answer, not DC. Okay, from the rectifiers we will not be obtaining any pure DC. We will be getting a pulsating DC. Pulsating DC is nothing but we will find some ripple content on the DC voltage. Okay. Now after taking the transformer, open the gallery and select the discrete semiconductors. And in discrete semiconductors, you will find the bridge rectifier circuit symbol. Okay. The third component is bridge rectifier. Okay. The output of the rectifier is pulsating DC, right? We need to use some filters for removing the ripple content. Okay. For that, okay, we can use any of the filters. In advanced charger circuits, there will be number of advanced filters. Okay, like LC or RC or like that. Okay, but for the basic model, we just need a capacitor. Okay, for that, open the passive components. Select an electrolytic capacitor. Okay, one more question. What is the difference between a capacitor and an electrolytic capacitor? Can anyone tell me? What is the difference between a normal capacitor and a electrolytic capacitor? Does anybody know the answer? What is the difference between a capacitor and a electrolytic capacitor? Okay, nobody is giving the answer. The difference is normal capacitors. Okay, that is not the correct answer, Mr. Lakshmi Narayana. Okay, the basic difference is if you observe the circuit symbol, you can say the answer. Okay, the difference is the electrolytic capacitors are provided with polarities. Okay, nothing but they will be indicated with some positive terminal and negative terminal. Okay, the other capacitors will not be having any polarities. Okay. Now, after filtering the output of the rectifier, the next step is to, okay, what is the next step? Can anyone tell me? After filtering the DC output, what is the next step?
Step down.
Okay, we have already used a transformer for stepping down the voltage. The next step is to regulate our output voltage because the step down
Regulator.
voltage. Okay, very good, Mr. We need to use a voltage regulator. Okay, can
Yes,
anyone
then
tell me
only you
what
can
does a
supply.
voltage? Okay, for getting the voltage regulator, you need to click on power supplies, and if you drag it to the bottom, you will find a voltage regulator. Okay. Can anyone tell me what is the operation of a voltage regulator? Okay. Respond quickly. What does a voltage regulator do? That's my question. Think carefully. What does a voltage regulator do? Increment or determine the voltage? Okay, that is also wrong. Okay, I think you did not get my point. What is the purpose of a voltage regulator? Okay, I'll explain it. Voltage regulators are used for maintaining constant voltage. Okay, the operation of a regulator is to maintain constant voltage. Okay, whatever may be the input to a voltage regulator, its output will be a constant value. Okay, suppose observe the voltage regulator here. It is 7805 voltage regulator, right? Okay, this is a regulator of 5 volts, because if you observe the series, the 78 is the series of the regulator and 05 is the output voltage. Okay, 05 is the rated output voltage of this regulator. Okay, you can identify the voltage levels of voltage regulators like this. Okay, 78 is the series and 05 is the output voltage. Okay, I think it is clear for everyone. Regulators are used for maintaining constant voltage at their outputs. Okay, now the final component is we will take the output through a load resistor. Okay, for resistor, go to the passive components and take a resistor. Okay, that's it. These are the components which are used in a basic model. Okay, but currently if we look at the circuits of our 5 volts chargers, in addition to these components, several other components also will be available. Okay, because we are having some super fast chargers and heavy chargers, right? Okay, along with these components you will find several additional components. Okay, for better performance they are increasing the circuits, but these components will be present inside of every charger circuit. Okay, this is the order and these are the components. Suppose I forgot to tell you, regulators, right, they are used for maintaining constant voltage at their output. Okay, now think of another voltage regulator. Okay, 7, I have told you that 78 is the series and 05 is the rated output voltage, right? Suppose if you want a 9 volts voltage regulator, the series will be like this. Okay, 7809. Okay, if it is noted as 7809, you need to make sure that it is a 9 volts regulator. And again, if you want a 12 volts regulator, the series will be 7812. Okay, like that you need to identify the voltages of a voltage regulator. Okay, now coming to the connections. Okay, this is the order of the components. Now we need to design the circuit. Okay, from the AC input directly connect to the transformer primary windings. Okay, after that from the secondary windings we need to connect them to the bridge rectifier. Okay, then now the output should be filtered, so the output of bridge rectifier must be connected to the capacitor, right? Just take the bridge rectifier output and connect it to the capacitor. Okay. Okay, take the ground terminal and connect it to the bottom side. Okay, and the reference pin of regulator can be connected to the ground. Okay, now my connections are completed. Okay, I will just change the input voltage and some values for getting the output. Okay, now we need to observe the voltage, right? For measuring the voltage, go to the measuring and you need to select the voltmeter. Just connect a voltmeter at the input side as well as another voltmeter at the output side. Okay, by this we can observe the voltages at input as well as output. Okay, I will just change the voltages and value some components. Okay, just click on the AC voltage source and I am changing it into 120 volts AC. Okay, 120 volts 1 H AC. Okay, I will explain the reason after simulation. Okay, I have given a 120 volts input and change the capacitor value to the maximum level. Okay, I am keeping it 2000 microfarad and change the resistor value to 1k. Okay, sorry, you can give 10 kilo ohms resistor. Now I am running the circuit. Okay, you can observe that the output voltage is a constant 5.43 volts. Okay, you can observe that input voltage is 120 and output is only 5.43 volts. Okay, due to some errors, as I have already told you, this is a dummy tool. Don't bother about the remaining values. Okay, like that we can design some simple circuits using liveware. Okay, now if you want to observe this output in graphs, okay, that also possible in liveware, but we cannot design the PCB layout for graphs in PCB designing because graphs won't be available. We need to use a CRO. Okay, for identifying the graph, just stop the simulation and click on gallery. Now go to measuring and you need to take the oscilloscope. Okay, for observing the graph. Suppose if you want to observe the output of the circuit in graph, then you need to take the
Hello, sir.
oscilloscope from the measuring. Okay, what is your doubt?
Sir, why here using the 10 kilo ohm resistor? It is any it is fixed or it is variable, sir? Suppose you change the any another resistance value.
Okay, okay, try it yourself, no problem, because for getting the voltages, okay,
Hello.
Your voice is not audible, sir.
Hello. Hello. Hello, sir. Hello.
Hello. Hello.
Sir.
Sir. Hello, sir.
Yes, sir.
Sir
Voice
went to
not audible.
offline.
Offline, huh?
Huh?
Okay.
Is the class done or what?
Huh?
Sir, voice is not audible.
Yes, I think. Santosh. Sir is going to offline, I think, na? Hello, sir.
Is my voice audible?
Yes, sir.
Okay, sorry, I have some technical issue.
Okay, sir.
My network is
Sir,
too slow.
and one more doubt, sir.
Okay, what is your doubt?
Here, we are using the bridge rectifier, na? Bridge rectifier.
Okay.
Another two
Okay.
rectifiers also is there, sir. Half wave rectifier and full wave rectifier. Why are you prefer to the bridge rectifier only?
Okay, in 5-volt charger circuits, they will not use half wave or full wave. They will be
Okay.
using only the bridge rectifier. Okay. Bridge rectifiers are used in your mobile chargers, not the half wave and full wave.
So your output is 5 volts. So then only you can you prefer to the bridge rectifier. Huh?
Okay, I did not get you. Come again.
No, sir. Our output is our preparing the 5-volt charger. Then only you can go the bridge rectifier.
Okay, whatever may be the circuit, whether it is a 5-volt charger or 12-volt charger, they use only the bridge rectifiers. Okay, but for
Half wave
better
and full
performance
wave.
your circuits, half wave and
Okay.
full wave rectifiers are not used. Okay, because they cannot afford the 5 volts output, and your output may not be perfect if you use a full wave or half wave rectifier. Okay.
Output is not okay. Output is not. What is difference between what is in these three rectifiers?
Okay.
Yeah. Continuous.
Now I cannot explain you the reasons
Okay.
for. Okay, sorry. We are
Hmm.
not dealing with the theory part because If we go to the explanation of half wave, full wave and bridge rectifier explanation, I need to come from the beginning because I need to explain all the operation with graphs. Okay. If you consider a half wave rectifier, your half of the wave will be considered and remaining half cycle will be not considered. And when it comes to the full wave rectifier, both of the half cycles in your signal will be considered. Like that, for considering the signal, we need to use a continuous output. Okay, that is the reason we use a bridge rectifier. In bridge rectifier, at a time, two diodes will be operating. Okay, if two diodes are on, the remaining two will be in off position. Okay, like that, if we use a bridge rectifier, the output will be perfect. Okay, I cannot explain you all the theory part. Just we need to do more circuits. Okay, if you are fast, I will give you the circuits. Okay, we are not dealing with the theory part. Okay, just I need to give you some circuits so that we will be designing the PCB layouts for these circuits. Okay, is that clear for everyone?
Sorry, suppose if you're giving the supply reverse, suppose minus plus plus minus, then what will happen, sir? It will working
Okay,
or not?
try it yourself
Okay.
and tell me what is the output. Okay, now there is
Okay.
no time for discussing about the circuits. Okay,
Okay.
now I am explaining about checking the graph output, right? For checking the graph, you need to, okay, now you can turn off your mic. Guys, if you have any questions, you can turn on or else mute your mics. Okay, for observing the graph in your circuit, or sometimes we need to observe the output in graphs, right? Okay, so then you need to connect a CRO. Okay, CRO or oscilloscope will be present at the measuring folder. Okay, if you open the measuring folder, then you can find the CRO. Okay, every CRO will have two channels, right? Connect the first channel at the input and the second channel at the output. Okay, now I am connecting the positive terminal of channel 1 at the positive side of my AC input voltage and the negative terminal at the bottom side of my okay, you need to connect the positive terminal at the top side and negative terminal at the negative side of the input supply. Okay, similar way, connect the channel 2 positive terminal at the positive side and negative terminal at the bottom side of your circuit or ground. Like this, you need to connect the CRO to your circuit. Channel 1 at the input, channel 2 at the output. Now click on the graph and you will observe a plus sign like that. And again, if you click on your workspace, you will get a graph. Okay, I will explain it again. After completion of the circuit, just wait, I will drag the circuit some more. Okay, click on the graph, click on the workspace where you have empty space. Then you can observe your graph is present at the, okay, select a place which is suitable for you. You can place the graph at bottom side or right side of your okay, okay, place it wherever you want. Now if you can play, if you observe the boundaries from 0 to 12 and from 0 to 6, right, you need to change the x and y coordinates. Okay, for that click on double click on the graph, and now change the maximum and minimum values. Okay, I'm keeping the maximum value at 180 and minimum value should be with minus sign. Okay, minimum value is minus 180. Okay, you can change the colors of your channels also. Okay, the first one is in red color and the channel 2 output will be in blue color, right? You can change the colors also. I am placing it in green. Okay, I am clicking on OK. Okay, now you can observe the boundaries of my graph. Okay, from 0 to 180 and 0 to minus 180. Okay, did everyone find the graph and change the values? Okay, wait, someone asked a question, I think so. How to get the graph? Okay, Mr. Tarun, I will repeat the process. Okay, just give me a second. Okay, I am deleting it again. Okay, for CRO, click on. Okay, is it not audible now also? Someone says that my voice is not audible. Mr. Rahman. Okay, thank you, Mr. Tarun. Okay, for CRO, click on gallery, go to the measuring folder. Okay, if you open the measuring folder, you will find oscilloscope. Okay, click on the oscilloscope, then you will find the CRO. Connect the channel 1 at the input side and connect the channel 2 at output side. Make sure that the plus wire should be connected to your positive side and the minus channel should be connected to the ground side. Okay. Now, after connecting the CRO, click on the graph which is available on the top side shortcuts. Okay, you can find the graph symbol beside to the delete symbol. Okay, to the right side of delete symbol you will find the graph symbol. Just give a click on it. Again you need to click on the workspace. Okay, if you give a left click on the workspace you will get the graph. After getting the graph you need to change the values, right? Okay, the boundaries are from 0 to 12 and 0 to 6. Okay, but my input voltage is 120 volts, right? Now I need to change the values. Okay, for that double click on the graph. Okay, after giving a double click, change the maximum value to 180. Okay, and minimum value should be minus 180. Okay, the maximum is 180, the minimum is minus 180. Okay, don't forget to give the minus 180, and you can change the output colors. Okay, suppose if you want the output of channel 1 in red color or some other color, you can change the colors also, but I am not changing the channel 1 color. I just change the channel 2 color to green. Okay, if you change it to green you will clearly observe the output. Okay, now I am clicking on OK. Okay, the time gap should be 2 only, don't change it. Okay, now I'm clicking on OK. Now if I run my circuit, you can observe the output graph. Okay, the input voltage will be in sine wave, and you can observe a small green line, which is the DC 5 volts. Okay, and the output is only 5 volts. That is the reason you observe a small line above the zero line. Okay, because the gap is from 0 to 60, right? Okay, you can observe the 5 volts DC output. A small green line is passing above the zero, which is okay. Okay, you need to stop the simulation first. Okay, for getting the graph or any other components, or if you want to make any changes in your circuit, stop the simulation first. Okay, you need to stop the simulation, then only you can change the, or you can make some modifications to your circuit. Okay, that is not a big deal, Mr. Lakshmi Narayana. Okay, don't bother about it. Okay, for AC supply, we use phase and neutral only. Okay, just for identification of the wires, it is indicated with plus and minus. Okay, don't bother about the symbol. Okay, okay, Mr. Vishwanath, did you find out your graph? Okay, Mr. Tarun, change the values. Okay, you can change the values because I have given the 120 volts input due to the graph. Okay, I want to observe the graph, right? As I have already told you, this is a dummy software. Okay, if you want to observe the graph perfectly, you need to give the values according to the graph. Okay, for observing the graph, I have given the 120 volts input voltage. Okay, the input voltage is in sine wave and the output is DC 5 volts. Okay, that is a direct straight line. Okay, if you completed the circuit, save it first. Okay, you need to save the circuit first. Okay, if it is completed, let me know. We will move on to the next circuit. Save the circuits because these are the circuits that you are going to design the PCB layouts. Okay, I will be giving you number of circuits. If you are fast, we can design more circuits as possible. Okay, there are plenty of circuits which are designed by us. Okay, we have done the practical work also with those circuits. Okay, we will be giving you some circuits related to ICs, etc. Okay, those circuits are already done by many of the students in AP engineering colleges. Okay, they have done the practical work also. I have pasted. Mr. Devakar, go through WhatsApp. In WhatsApp, they have the link of softwares. Okay, is it completed for everyone? Please respond. I will give you another circuit. Okay, thank you guys. We will move on to the next circuit. Okay, save the circuits. Don't forget to save. Okay, because I will not be giving the circuits again. I will directly go to design the PCB layout of these circuits. Okay, then you will suffer if you don't have the circuit with you. Okay. Okay, this is 5 volts charger circuit, right? Now we have designed. The next circuit name is a simple fire alarm circuit. Okay, for that you need a battery from the power supplies. Then you need a resistor. Okay, take 2 resistors. And from the passive components, take a capacitor. Okay, after that, go to discrete semiconductors. Then you need a diode and drag it down. You need an NPN transistor. Okay, a fire alarm circuit will require a sensor, right? Okay, to detect the fire, we need a sensor. Okay, that sensor is called as thermistor. Okay, or temperature sensor. Go to the input components and take a thermistor, which is a temperature sensor. Okay, the output will be absorbed in a speaker or buzzer, right? I have told that a simple fire alarm, right? Okay, to give the alarm, we need a speaker or buzzer, right? For that, go to output components, take a buzzer from the audio session. Okay, in output components, take a buzzer. Okay, these are the components which are required for the circuit. Okay, the circuit name is a simple fire alarm circuit. For rotating the component, select the component and click on Ctrl plus R. Okay, open the gallery. From input components, as I have told you earlier, every sensor will be in input components only because sensors are input devices. Okay, from the sensors, take a thermistor, which is a temperature sensor. Okay, and you will find the diode and transistor in the discrete semiconductors. Okay, the diode and transistor will be in discrete semiconductors. Okay, now connect the circuit. Okay, the connections are completed. I need. Okay, some values of the components should be changed. Okay, that is enough. The capacitor value should be 10 microfarad and the resistor value should be 10K. Okay. Now if I run the circuit and change the, okay, you can vary the temperature here because this is the manual process of varying. If you consider a digital sensor, then it will take the values directly. Because it is a simulator, we need to change the value, okay, with our hand. Okay, you can decrease and increase the temperature value like this. Okay, go to the bar which is present to the left side of your thermistor. If you place the cursor over it and drag it from top to bottom to change the values. Okay, now I am simulating the circuit. If you change the temperature value, you can observe that the buzzer will on. Okay, whenever the temperature increases, the buzzer will turn on. Okay. Okay. Is it completed for everyone? Okay, save the circuits. Okay, complete the circuit. And if it is completed, save the circuits first. Okay. Tomorrow I will give you number of circuits which are designed by using ICs. Okay. Okay, that's it for today, guys.